the frequency modulated signal, if m of t has a PDF, then the RMS frequency deviation is. Here from the above equation, delta theta is nothing but k minus infinite to t m of tau d tau. So we want frequency deviation, that is delta of omega, that is the differentiation of delta t theta, which is equals to k m of t. So delta f equals to k by 2 pi m of t. Here delta f RMS equals to k by 2 pi. The RMS value of m of t, that is whose PDF is fm of m, is 2, which is nothing but k by pi, which is option D is correct. Here RC is 2k. Here GM is alpha by RE. Alpha is beta by beta plus 1. Here, after getting the gain, V0 is nothing but V0 peak to peak is 2 of ICQ R. Here ICQ is nothing but GM into VT. So here R is nothing but RC. So after substituting all these derivations, means whatever the values we have, we are going to get V input peak to peak swing is 80 millivolts. Here options are 40 millivolts, 60 millivolts, 80 millivolts, 100 millivolts. Hence option C is correct. Here the question is, the input Vi to the circuit shown in figure below is a square wave of amplitude plus or minus 1 volt and the frequency is 100 radians per second. Here this is the circuit is connected in inverting configuration, that is the gain of the amplifier is, suppose I am representing a gain with A, 1 by j omega c by R, that is 1 kilo ohm. Here the magnitude of the gain is magnitude of this, that is 1 by 100 into 10 power minus 6 divided by 10 power 3, which is equals to 10 power 6 divided by 10 power 5, which is equals to 10. Gain is 10. Hence the output peak to peak amplitude varies plus 10 to minus 10. Hence the peak amplitude of the output voltage is going to be 10 volts. C. Option C is correct. For a unity feedback system, G of S equals to 200 by S into S plus 8 and R of t equals to 2t. To reduce the steady state error by 5%, the new value of gain is, we know the steady state error ESS is given as limit S tends to 0 S into R of S by 1 plus G of S H of S. Here R of S is equals to 2 by S square, which is 2t, the Laplace transform of 2t. H of S equals to 1. So ESS equals to 2 divided by 1 plus limit S tends to 0 S G of S. This is 0, so this one. So which is 2 by kV. kV is nothing but limit S tends to 0 S G of S. So which is equals to 200 by 8, which is equals to 25. So ESS equals to 2 by 25, which is equals to 0.08. So if we reduce the steady state error by 5%, means the new steady state error is equals to, this is the new one after reducing, equals to ESS minus 5% means 5 by 100 into ESS, which is equals to 0.076. So now the new steady state error is given as 2 by limit s tends to 0 as k by s into s plus 8 is equals to 0.076. Means if we solve this equation, we will get k as 210.52, which is option B is correct. So the question is, match the least one with least two, referring to the 8085 microprocessor. Here least one, RP means written on positive, RPE means written on even parity, or Z means written on 0, or NC means written on carry. Here P means parity, CY means carry, Z means zeros, S means sign. These are least 2 indicates the flag conditions, whereas least 1 are the instructions. So written on positive. Positive means if sign bit is 0, it is going to be written. Hence P is matched to the 4. Written on parity even means it is depending upon the condition, that is parity bit. So it is matched to Q is 1. Written on 0 means it checks the 0 flag, that is R is 3, and S is, that is written on carry means it checks the flag condition of carry, that is 2. So P4, Q1, R3, S2. Hence option C is correct. Question is in the figure below, L1 equals to L2 equals to 2 henries, R1 equals to R2 equals to 10 ohms, I0 equals to 5 amps. If RL equals to 1 ohm, find the drop across the RL at t equals to 0 plus, following the opening of the switch at t equals to 0. Assume steady state before switching. See, at t equals to 0 plus, we need to draw the diagram. So at t equals to 0 minus, at t equals to 0 minus, IL2 of 0 minus equals to 2.5 amps. IL1 of 0 minus also 2.5 amps, because the resistances R1 and R2 are equal. In the steady state condition, L1 and L2 acts as a short circuit. So I0 is equally divided between R1 and R2. So the magnitude of I0 is 5 amps. Hence the IL2 of 0 minus is 2.5, IL1 of 0 minus equals to 2.5. So at t equals to 0 plus, IL2 of 0 plus equals to IL2 of 0 minus, which is equals to 2.5 amps. Hence the voltage across the load resistor at t equal to 0 plus is equal to 2.5 volts, which is option C is correct.